We are now going to look at the final type of shifting there is, and that's the horizontal shifting of trig graphs. Sometimes it is called the phase shift. And it's called the phase shift just like you have the phases of the moon, right? You have a crescent moon that goes to a half moon, that goes to a full moon, that goes back down to a half moon, that goes back down to a crescent moon, right? It's moving along the x-axis. That's why it's called a phase shift. All right, so what we have down here is I have a graph originally, and then on top of it, I loosely traced it, and I have the dots. And you can see what happened here was, what you have to realize is that I can have a cosine wave. See this pink one looks like an upside down cosine wave that then got shifted to the right. Or I can look at it as a sine wave. I can find the middle of the lowest and the highest point, which looks to be right there, and I can say it's a sine wave. There's my hill starting to make a valley. And that's the beauty of the phase shift. It then allows you to see it as a cosine or a sine wave. Neither is more correct than the other. So let's just start kicking through some examples. So one thing we need to remember is a phase shift occurs here within the x. Remember, the general formula for a trigonometric function is a, and then we could use sine or cosine, b x minus c plus d. So we're looking at this part right here. And if you remember from 8th grade, we're talking about the horizontal horrible child who is going to do the opposite of what he is told. And that's because we need it to make the y value be 0. So if we look here, we have the same thing going on. We have our amplitude, we have our frequency, we have our vertical, and now we have our phase shift. So I'm going to look at this, since you guys were actually pretty good at this, with no phase shift. I just look at it as -2 sine 2x plus 2. I graph that. All right, so we started off with saying that this tells us there were 2 sine waves in 360. I know a sine wave starts as a hill, and then it's followed by a valley. So there's one sine wave in 360. And just to keep it going, I'll put a second one in there, even though I didn't tell you to do one complete cycle. Just want to get a good picture of it. So there. I have 2 sine waves. Good. I got that done. I also have an amplitude of 2 going on right here. If I made this 2, we'll call this -2. I don't have the negative part going on yet. So let's take all these dots. I'm going to group them together. And then since it's a -2, that means to just flip. Boom, there we go. Now I have the negative part of the amplitude. And now I'm going to shift up to 1, 2, and the last thing that I'm going to do now is my phase shift. So my phase shift here says plus pi over 6, or 30 degrees. That's why I worked this in 30s, 30, 60, 90. But remember, since it's the horrible horizontal child, we're really going to move to the left pi over 6 spots. So that means I'm going to pick an easy one right here, and since they're all connected, we're going to take this guy right here and we're going to move him 30 degrees. There. Done. Now I'm only going to trace what I see in the 2 pi, because I'm going to come over here to Desmos. And there you have it. If I were to take a screenshot of this, you can see it's the same thing. Now I did this, remember 2 pi is really 6.14, and here it is at 6.14. It says I have a peak here just under 2, and there's my peak right over there. Okay, so for example 2, we have no vertical shift going on this time. Woo! We just have a regular phase shift going on. So again, I like to look at it as 3 sine 1/2 x, and then I'll do the phase shift. All right, so this is telling me I have half of a sine wave in 360. So I know a sine wave starts high with a hill, and its amplitude is 3. So that's what a regular sine wave looks like, but I only want to see a half a wave here in 360. All right, so that means I just want a hill to occur in 360. And if I were to go backwards, that means in negative 360, I want to see 1, 2, 3, the valley. All right, so this is what I have here. Do I have an amplitude of 3? Yes, 1, 2, 3, 1, 2, 3. Do I see half a sine wave in 360? Yep, here's 360 right here, and there's half a sine wave. So now I'm going to put all these together. Now I can group them, and all you would do is just move them. Now I have to move them a phase shift of 5 pi. And remember, it's horrible horizontal. So I'm moving to the right 5 pi. So I'm going to start with this guy back here and move him 5 pi's. 1, 2, 3, 4, 5. Well, his brothers and sisters moved off the page, but that's not bad because I can just move everybody the same. So they had 1, 2, 3, 4 here. So 1, 2, 3, 4. There's where it's going to reach 0 again. And in between here, thank gosh there's no vertical shifting going on. And then in between here, 1, 2, 3, 4. And then this would be right in the middle, down 3. So let's see what my sine wave is going to look like. Let's make this a little thick right here. Up, down, and good. So again, I'm doing this from 0 to what is this, 5 pi. Usually you're going to only have to be asked to draw one complete sine wave. So once again, let's go to Desmos and see if our picture matches up. All right, so there is my equation. And here you can see with the screenshot, it looks pretty much exactly the same, with its peak coming here at about 6.28 and our peak here coming at 6.28. Now the last one's a little tricky. And that's because we have to look right here at what's going on. This is how the Regents and other tests would like to trick you. If you look back here at this last one, you'll notice we had double sets of parentheses. And that's because when we do write a general form for a trig function, it's A, the function, B, parentheses, and then the phase shift is by itself in parentheses. So here you have to be aware that you have to do a little factoring. You have to factor out to get the phase shift by itself. So when I factor this out, it becomes y equals, well, the amplitude doesn't change, and the fact that it's a cosine wave doesn't change. I'm going to factor out a 2 so that the x is alone, and this becomes minus pi over 2. And oh, boys and girls, you have to be good with basic math. If you're sitting here looking at me going, oh my God, how did you get that? It's because when you distribute, you should get the original. 2 times x is 2x, 2 times pi over 2. The numerator and the denominator cancel you out, leaving you with pi. If you can't understand that, consumer math is first period down the hallway. So anyway, that's basic, guys. It's basic. So let's move on to graphing it. So what we do is we're going to do the same thing. We're going to, as I do it, I'm going to ignore the phase shift and do 3 cosine 2x plus 1. And then phase shift everybody. All right, so this means I need 2 cosine waves in 360, and their amplitude is 3. 1, 2, 3. So then I go down in between 1, 2, 3. So yep, there's 1 cosine wave in 180, and then if I did it again, I would have my second cosine wave in 360. Now I'm going to group these all together, because that's easy to do on a smartboard. And now they all have to be vertically shifted plus 1. Okay, so everybody moves up 1. Yay! And now I can apply my phase shift. So my phase shift, remember here, is minus, so that means we're going to the right as a horrible horizontal child, plus pi over 2 spots. So everybody moves 90 degrees. And since my grid is set up as 90 degrees, if I drag one 90 degrees, they all move. So now let's join them together. And that's what a phase shift would look like. Now I could also look here and say, all right, I can make this come down to here, and it looks like it would go right about there. So once again, I'm going to go to Desmos and check myself. Here is my original. I'm going to go back to my original. Make sure this matches my original. And where is it? It looks like 6 point. So let's take a screenshot of that and see if it matches up. And indeed, it does match up. It says 0, -2. I have 0, -2 right here. It tells me I should have a high here at 90, 4. So pi over 2, 4. Yep. And I should end at 2 pi at a -2. Bingo. So tomorrow in class, we're going to talk about how to write the equation if they give us the picture.